Free response question number 4, part C. For t between 40 and 60, must there be a time t when Ben's velocity is 2 meters per second? Justify your answer. Now initially, when we look at our two velocities at 40 and at 60, I have 2.5 and 4.6. So it seems as though we would have just gone from 2.5 up to 4.6, which doesn't necessarily go past 2 meters per second. However, it could be that the velocity decreases from 2.5, gets down as low as 2 or lower, and then increases up to 4.6. How would we know? Well, if we can figure out the average velocity from 40 to 60, so from a position of 9 to a position of 49, then we can determine whether or not the actual velocity had to equal 2 at some point. So remember, the average velocity is also the slope of the secant line. So we find the average velocity by taking the slope of the secant, which would be 49 minus 9 over 60 minus 40. So 40 over 20 is 2 meters per second. So the average velocity is 2 meters per second, or also known as the slope of the secant. So the mean value theorem states that if a function is continuous and differentiable, then the slope of the derivative, the slope of the tangent must equal the slope of the secant at some point on that interval. So does the mean value theorem apply? Well, only if you're told that the function is continuous and differentiable. And since you're told the twice differentiable function b models Ben's position on the track, then yes, the mean value theorem applies. So you can say, according to the mean value theorem, since b is twice differentiable, v of t must equal 2 meters per second at some time between 40 and 60, because the average velocity is 2 meters per second.